Welcome back. Hey, new week, but that's all right. Hey, we are on week 2 of school at home, and I hope you're having a good time. You know, these particular lessons that we're doing for geometry, I do wish you were here to be able to, I can see how well you understand and all that, but I'm depending on you. If you don't understand, to watch the video again and again and again. I'm going fast, but you get to watch it over and over again. Let's review a little bit of what we learned so far. Last week we were talking about in geometry some of these basic points. For instance, this is called a what in geometry? That's right, a line, a line. It goes on forever, in both directions. It reminds me of God, no beginning, no ending. This is called a what? That's right, a ray. A ray has a beginning but no ending. That reminds me of people. People have a beginning. We're not like God. We're not eternal, but we have a beginning. But God, like God, we don't have an end. We live forever. All right, this is a what? A segment. A segment reminds me of, an animal has a beginning, has an ending. And we also talked about a point. Now, a point is lettered with a capital letter. Remember that. Now, sometimes lines on the same plane can intersect, and these are called what? Intersecting lines. Sometimes those lines never intersect, and those lines are called parallel lines, which I don't have a picture of right now. Some lines intersect in a special way. They make square corners. All right, now anytime I say the word square, remember you're supposed to look away, not look at me on the video. That would hurt my feelings. Back in high school, square meant somebody that wasn't with it, somebody that was out of the loop. And I don't want to be called a square, so don't look at me when I say the word square. Now, when lines meet and they make square corners, what do you call that? Those are perpendicular lines. All right, let's look at what we learned about angles. Not angels, we're talking about angles here. If you have two rays that have the same, what's called the endpoint or the vertex here, that's called a what? An angle. Let's suppose there's an angle that has a measure that's less than 90 degrees. It's a very what? Very cute. It's an acute angle. Oh, it's so tiny. All right, what do you call an angle that makes a square, remember to look away, square corner? Well, that's called a right angle. All the others are wrong. All right, what do you call an angle that's more than 90 degrees? Obtuse. Boy, it's a big angle. But here, what doesn't look like an angle, it's not a line because it has this one vertex. These are two rays going opposite directions, and they make what kind of angle? A straight angle, 180 degrees. Now we learned about vertical angles formed by intersecting lines and the opposite angles are equal. We learned about complementary angles that add up to 90 degrees. And we learned about supplementary angles that add up to 180 degrees. Now today, we're moving on. And by the way, 9.4 is called what? Classifying triangles. Not angles, but triangles. You can follow along with me on page 471. Normally I would be saying, hey, highlight in your book as I go. Don't do that in your math book. That's actually my math book, the school's math book. So we don't want you to highlight in that at all, okay? But you can write notes or things like that on a piece of paper about what we're talking about. But the instructions, if you miss this, they're on page 471 too. When it comes to classifying triangles, let's define first what a triangle is. Well, a triangle is a closed figure, all right? It has 3 sides and it has 3 points. For instance, this is not a triangle. There's one side, another side. And you say, well, it has 3 sides. But it's not a closed figure. You see this opening right here? A triangle has to be a closed figure with 3 sides. It also has 3 angles. I challenge you to draw a triangle with more or less, fewer than 3 angles. Try it. And it also has 3 sides, 3 angles, and it's a closed figure. 3 points, 3 vertices here. Now, how do we classify triangles? Well, first off, here's how you name it. You draw a symbol in front of the names for the points, so the vertices. So you would draw this triangle ABC. This is called triangle ABC. Triangle ABC. You would say triangle ABC. But remember to use this symbol in front of the letters to show we're talking about a triangle. It has the sides, AB, looks like a segment, right? Because the sides are made of segments. Segment AB, segment BC, and segment AC. Now I could call those segment BA or segment CB. or segment CA. That's okay. But make sure you name them as segments. It has points with capital letters A, B, C. Now, one thing that I hope you learned last week when we were working on drawing a triangle and cutting out, finding its total angle measures. If you add up angle A plus the measure of angle B and angle C, you add up those three and you would get 180 degrees. Every triangle, if you add up the angles inside that triangle, it adds up to 180 degrees. That is pretty cool because that's really a whole basis for a different kind of math, and it helps so much to know that. All right, so there are two ways to classify triangles. Two ways. First off, you can classify the triangle by the angles. For instance, if the triangle has three acute angles, oh, they're so cute. These are all less than 90. Those three acute angles make the whole triangle a what? An acute triangle. Now, of course, I'm looking at the angles, not the sides here. Just looking at the angles, I'm classifying it by that. It's called an acute triangle. It has three acute angles to it. There are also right triangles. All the others are wrong, I guess. Well, there are right triangles, and the right triangle has one right angle. Do you know it's impossible? Impossible for a triangle to have two right angles, because right angles are 90 degrees. And if you add up 90 plus the other right angle, 90, you get 180 already. That doesn't leave any degrees for the third angle. You can't make a triangle that has two right angles. Well, anyway, try it. Let me know if you do it. All right, so it has one right angle, therefore we call the whole triangle a right triangle. Wow, that's pretty interesting. Now, so if it has one right angle, it's a right triangle. If it has all acute angles, it's a what? Acute triangle. Now also, based on its angles, not looking at the sides, you also have what's called an obtuse triangle. And that means where one of the angles is obtuse. Can you see which one will be obtuse? Well, this one's acute, that one's acute. But this one is more than 90 degrees. I know it doesn't look like it, but take my word for it, it is. All right, so that would make this whole triangle an obtuse triangle. So all you can have is one obtuse triangle angle in a triangle. So that would be an obtuse triangle. Okay, so let's name the three ways of classifying triangles based on the angles. There's the acute triangle, the right triangle, and the obtuse triangle. Okay, so come over here and let me see if you can understand what I just said. Here I have a triangle with 70 degrees, 55 degrees, and 55 degrees. Based on its angles, what kind of triangle is that? Da, 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 da. Which one of those three? You're right. I hope you said acute. Why? Well, all three angles are less than 90 degrees. So therefore, they're all three acute angles. How about this one? 40 degrees, 120 degrees, and 20 degrees. All right. Da, 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 da. What do you think? What kind of triangle would that be based on its angles? Well, see the big one here, 120 degrees? That's obtuse, isn't it? That's an obtuse angle. So therefore, the whole triangle is called an obtuse triangle. Pretty obtuse, huh? Now, how about this one? That means a 90-degree angle right here. 30 degrees, 60 degrees. Notice they add up to 180? All of them add up to 180? But anyway, what kind of triangle would that be? You're right. Get it? Right triangle. All right. Now, the second way to classify triangles, not based on the angles, but based on the sides, the lengths of the sides. All right. So you got to be able to do both of these and understand them. So by the sides, first off, if all the sides are equal in length, and remember those markings show you that the sides are equal. Each side has one red mark on it. That means they're all equal. All right, well, if the sides are all equal, hear the word equal in that? They're equilateral. It's called an equilateral triangle. All the sides are equal. All right, suppose there's only two sides equal. Now, this is a big word, isn't it? And it's not familiar, all right? If two sides are the same length, and I did it this way, I could have used one mark on each of those. It's okay. But if two sides are equal, but not the third side, it's called isosceles triangle. Let's say that together. Ready? That together. I get it. Okay, now let's say isosceles triangle. Ready? Begin. Isosceles triangle. Okay, so that's not isosceles, right? Isosceles, no, it's isosceles triangle. It has two sides. Now, let's suppose none of the sides are equal. I didn't put any red marks on those because none of those sides are equal to the others. There are three different measures for each side. So, each side has a different measure. That's another unfamiliar word that you gotta learn is scaling. Scaling triangle. Let's say that word, right? That word. Okay, I don't know if you're catching on, but if I say that word, anyway. Scaling triangle. Let's say scaling triangle, right? Scaling triangle. Scaling triangle. Three sides, all different lengths. Okay, let's come over here. What kind of triangle is that then? Over here, let's look. Do I have any markings? No. That means I'm telling you, they're all different lengths. What is it? Right, scaling. How about this one? You notice I got one mark on each one. So that would be equilateral. I won't have time to write it, but that's equilateral. How about this one? Only two sides are equal, so it's a what? Isosceles triangle. Isosceles triangle. Well, let's use this information to solve one more thing, then I gotta go, all right? And you work on this or watch this video over and over. You can look again in the book on how to do this. You can go to classzone.com and they'll show you how to do that on classzone.com. There are all kinds of ways. You can give me a call, all right? Give me a call. I'll be glad to help on any of your math, all right? So let's say this. I have two angles that I know on a triangle, 46 degrees and 21 degrees. And you're going to be asked in just a moment to find the missing measure. The missing measure is x here in this case. Well, here's what you do. You say, well, I know these all add up to 180 degrees. So 46 plus 21 plus whatever x is, the variable, is going to be 180. 46 plus 21 is 67. Plus x equals 180. Well, what? Plus 67 equals 180. Well, I'll just take 180, subtract 67. And what do I get? Is that right? $67 plus what? 113 equals 180. So what is x? X equals 113 degrees. How many agree with that? Because I could be wrong. Yeah, that looks right to me. All right, well, I look forward to seeing you tomorrow when then we're going to be talking about classifying quadrilaterals. See you then. Bye-bye.